Autonomous system, or shortly known as AS. Autonomous system is a small building block, independent building block of the internet. When we think about internet, we usually think about something big, dramatic. For example, a BGP protocol, a bigger protocol for internet communication. Or as in a British sitcom called The IT Crowd, Jane there, she was about to turn off the internet and it was perceived as an apocalypse. And we usually tend to, even those people who started learning more about tech, learning more about how networking works, they still think internet is something very, very big and unknown. Well, it is very big, but we need to learn more and more in order to make it less unknown for ourselves. And before we can go into more advanced topics like BGP, we need to understand basic building blocks that protocols like BGP use in order to ensure we have a communication on the internet. It's used for anything that you need internet for. Communication, internet, surfing on your browser, etc., etc. So, autonomous system, AS, would usually be known to you as ASN. People usually, when I say AS, they're like, what is it? And when I say, oh, ASN, oh, now we know what ASN is. It's the number that internet service providers have, ISP. That's the usual context that people perceive ASN, what ASN is to be. However, ASN is much wider than just the ID or network that our internet service provider has. The use case, how ASNs or AS autonomous systems came around. We needed administrative control around lots and lots and lots and lots of routers. We had different organizations and we have different organizations, be it institutions like universities or government institutions, be it private institutions like AWS, Google. All of them form internal networks consisting a lot of different routers and switches. Imagine a big university's server room like MIT's or Harvard University's server room. It must be massive in terms of networking aspects only. I'm not even talking about servers themselves. And then we needed public communication so that those routers could communicate to each other and deliver the information to form what is known now as internet. In order to achieve that, we needed some administrative control, right? What we basically needed, on a basic high-level diagram, we needed hops, right? Different hops, and we needed to ensure communication between those hops. Full communication, to make sure that information reaches its destination. What is internet? It's when we send the information and receiver receives the information. Be it when we request a web page from Google's web server in order to see Google search results. Be it anything else. It's an exchange of information. And in order for this exchange to be successful, we need our information to reach the next hop. And if the hop that we're aiming to reach is too far, our information needs to make a few hops, a few jumps in order to reach that information. And we needed an administrative control in order to form those hops through which our information can pass. These hops were called autonomous system. Autonomous system is one or more routers that represent a single hop. It's an administrative control over a single network, right? We don't care whether they have more routers or switches working privately, right? But on the outside, it's one public administrative entity. Apologies, it may not necessarily be public, but it's one administrative entity. And that administrative entity receives an ID, receives a passport, right? Autonomous system number, ASN, that's a passport. It's similar to cities, for example. One city can have different administrative control points inside, right? But on the outside, it's one single city. It's New York, it's London, it's Boston, it's Seattle, right? It's one single city through which you can pass when you're going from destination A, from point A to point B. Now a bit about numbers, because ASN is not a number off the top of our heads or off the top of regulation that issues them. It's a very controlled way of issuing ID in order to make sure that not a single ASN has copy or has a similar ID for clarity purposes. From the very beginning, when ASN became a thing, we had 16-bit numbers, 16-bit or 2-byte numbers. And those numbers in a numerical, human-readable format were numbers from 1 to 65,535. So any of these numbers could have been allocated to an ASN based on the application that necessary body receives. From 2007, they felt that there are not enough numbers because basically what they had is around 65.5K numbers for ASNs, and they introduced 32-bit numbers or 4-byte numbers. And those were from 65,536 to, to 4,294,967,295. So from that number to this number, if that makes it easier. Now we have a vast majority of different ASN numbers, more than 4 billion, but most of them are reserved. You can't get ASN numbers that easily. You can't just collect documents, go to the body and say, you know what, I want an ASN number. I feel independent enough now. That's not how it works. In order to receive an ASN number, you need to provide enough evidence that you can be an autonomous system, that you are big enough, that you have your case. For example, you are an independent organization like a big university that has different networking levels for students, for employees, for researchers, for guests, etc., etc. There are public ASN numbers that we may basically care about when we talk about ASNs. It's very rarely that someone cares about private numbers when they talk about ASNs. So public ones are mostly the identification of ones you see for internet service providers or companies. And there are private ones. We won't be touching private ones too much because the logical question would be, why would we need private ASNs? Why would we need to register them if they are private? They must be behind the public ASN, right? And you are correct. Private ASNs are usually assigned numbers between 64,512 to 65,534. And we don't care that this number is actually very small. We're talking about 1,022 numbers, right? It's because we are fine if there is an overlap, okay? Because it's on a private level, it's behind public ASN. We never see actual ASN IDs, private IDs. For example, again, let's focus on a university, on an MIT. MIT is a massive university. It has offline students who go to university campus to study. They have online students who undertake courses online. They have a vast amount of staff, researchers, professors working for them. They might create different network segments. Don't confuse it with network segmentation, because they might create different administrative network segments to make these departments or these different types of people that engage with the university completely separate, okay? So that they never touch each other in terms of the network. Researchers can work on a very expensive or important or confidential / classified research. Students can work on something else, and they need this segregation. That's why they might assign private ASN numbers for traffic to be routed between those private ASN numbers within their organizations. That's why we're not too concerned about private ASNs, and it doesn't come up often as a use case. In order to register an ASN, you need to submit your application to regional internet registries, shortly known as RIRs. There are different registries depending on which region you are in. It can be RIPNCC, which is for European region. I suppose it's EU and as a European continent. It can be ARIN for North America. And it can also be APNIC, Asia Pacific region. Obviously, whether they decide to provide you an ASN number or not, they usually don't overlap. Therefore, these entities communicate between each other. Now we're going to more commonly asked logical question. what is the most common use case for asking for an ASN number? If we mostly see it with internet service providers, then is it internet service providers that usually ask for it, or what? It's a very good question, and answer to this question would also provide an answer to how ASNs help in global routing for the internet. We have stub autonomous systems, right? Stub autonomous systems can also be called useless autonomous systems because they don't contribute to internet communication. These are self-servicing autonomous systems. Why? So these are autonomous systems that again don't provide any transit. No traffic passes through that autonomous system in order to reach the destination, okay? And they usually connect to another autonomous system, ISP, for an upstream. Why do we even need them? Well, they can be companies that are working, that feel like they need to have their own autonomous system number. They are usually smallish companies, but I don't mean companies that are 30 to 50 employees big. They are certainly bigger, but they are not Google big, they are not AWS big. And they might be working on some classified stuff or on some stuff that makes them a good candidate for autonomous system registration. That's why they do get ASN, right? They do get ASN if their application is approved. And then as a hop, stub, okay, they connect to another ASN of an ISP, one ISP. And then ISP routes their traffic further on the internet, okay? Internet. Again, no transit, one ISP upstream, and in terms of the wider internet communication, they are sort of useless. Multi-homed ASN. Multi-homed ASN, again, provides no transit, so it does not contribute to overall internet communication. Multi-homed ASN is for bigger companies that, first of all, again, bigger than those that are stub ASNs, but they also connect to different internet service providers at the same time. They do it for high availability because they are afraid that if one internet service provider fails, then another one will be used as a failover in order to reach certain destination. Or for latency concerns, they can use several ASNs in different regions in order for their traffic to be closer to end customers. For example, they get a multi-homed ASN, gets an ASN number, and they connect to one ISP, another ISP, and maybe third ISP, okay? And these ISPs further traverse their traffic in order for it to reach its destination. It doesn't provide, again, transit. I'm repeating it again. You might think that I forgot that I already said it and I repeat it, but no. I repeat it so that you understand. Having ASN number doesn't necessarily mean that they contribute to internet communication, okay? And the last one, last but not least, the most important AS types, autonomous system type, is transit AS. It does provide internet transit, and usually it is for a pay. As a rule of thumb, they do it for money. Maybe there are those that do it for, I don't know, volunteer to do it, but it's very rarely. Transit AS, autonomous systems, is the reason why you can see my video at the moment, because they directly contribute to internet communication flow on a wider level. They form this route that BGP, main protocol of the internet, uses in order to deliver traffic from point A to point B. Transit ASNs are usually ISPs, internet service providers, or bigger cloud companies. It can be an AWS that play an important role in traffic, in internet communication on the internet. So it's not only ISPs that ask for ASN number on the basis of being a transit autonomous system, but also bigger cloud companies. They do provide internet transit, as we say, and they make money off the internet transit. What the terms and conditions of their earnings? It depends on the traffic volume, depends on different factors really. Maybe there is a fixed cost. We will not be going into details of that in this video because terms of conditions are different for different companies. On a basic level, different ASNs connect together using BGP, Border Gateway Protocol. So for example, we have Autonomous System 1, Autonomous System 2, and Autonomous System 3. These little circles that you see within autonomous systems are routers. It is to show you that one autonomous system does not necessarily have one router that the traffic goes through, okay? It may have many different routers inside of it, and as an internet gateway, it can use its main router, okay? So different ASNs communicate with each other in order to form the communication on the internet. So we may have a third ASN here, fourth autonomous system. And in order for ASN1 to communicate with ASN4, it will hop through AS3, AS1, AS3, AS4 in order for traffic to go from 1 to 4. Okay? AS3 is simply a transit here. It doesn't read the traffic, it doesn't decrypt the traffic, it simply does a transit for AS1. We have different versions of Internet Gateway Protocol, of Border Gateway Protocol, I have mentioned it several times and you might think that it's usually used on the internet. And it is right. So there are two versions of BGP, Border Gateway Protocol. By the way, I will have a separate video on the Border Gateway Protocol. Maybe at the point when you're watching this video, I already have it, so you're welcome to have a look. We have eBGP and iBGP. eBGP is external BGP, and it's the version of BGP that is usually used for internet communication. It connects different autonomous systems together for transit and in order to deliver internet traffic from point A to point B. And we have iBGP. iBGP is usually used within same autonomous system. Remember we were talking about private autonomous systems within one public one. So when we serve a lot of people, a lot of different customers and machines within one entity. It can be a university or it can be a government cloud. We need to use iBGP in order to make sure that there are routes between autonomous systems, private autonomous systems that we use internally. How does BGP controls path of autonomous systems? So how does it form it? Routes for transit autonomous systems are advertised on the internet. When we say advertise, it's similar to, hello, my routes are, so these are the routes that I know. In order to reach New York, I fly from London. In order to reach Argentina, I fly from Johannesburg, etc., etc. So you basically tell them how you reach different routes, and that's how you advertise your routes. And other routers use this information, BGP uses this information in order to put together logically faster routes. BGP uses AS_path, which means autonomous system path, in order to put together paths that we use in order to communicate on the internet. Path usually looks like this: 789, 456, 123. And how do we translate this path? It basically means that traffic will go through AS 123, AS 456, AS 789. For autonomous system types that do not export routes, for example stub AS or multi-home AS, they do not advertise their routes, meaning that they say we do receive traffic, okay, but we don't want for traffic that is not destined to be sent to us to be routed through us. They use different techniques in order to make sure that it happens. They obviously don't advertise their routes to start with on BGP, but there can be a couple of gaps in BGP. For example, there can be a BGP hijacking or different types of attacks that can make their routes to be advertised. In order to prevent those attacks or those gaps, limitations, they also have firewall rules in place. For example, they accept traffic that is routed to their IPs only, and they do not let any other traffic to transit through them, because obviously they don't want to transit any traffic, and they don't export BGP routes. Whereas transit autonomous systems usually advertise their routes in order to prevent any loops. For example, so that traffic is not routed back to AS 456, okay, so that there is no loop in the traffic flow. 123, 456, 789, and then if it goes back to 456, there is a loop, okay? And we don't want this to happen. That's why when routes are advertised, BGP always does the checks to check for any loops and prevent this from happening. This was a short or not so short introduction into autonomous systems. And autonomous systems is, as I said, building block of the internet that you need to understand in order to have an idea of how these building blocks put together what we know as internet. Thank you for being with me today. Don't forget to like my video, to subscribe to my channel, and see you in my next video. Thank you. Bye.